Hey guys, hopefully you're looking for another explanation. Again, this time it's practice sheet number 4, problem number 2 of the balancing chemical equations. This is another word equation, and that's what we're going to have at the end. And you're going to need that because, again, when we finish up with the stoichiometry, it's going to be all about the word equations at the beginning, and you have to be able to do just what we're doing right here. So we have magnesium reacts with sodium fluoride to produce magnesium chloride and elemental sodium. So magnesium is all by itself, so we're going to go ahead and write that element down. So the symbol for magnesium is Mg. Now again, if you can't find that, you need to go to your periodic table in your packet. Then we have sodium fluoride. Sodium fluoride is a type 1, no Roman numeral here, and it ends in I, so that means it is binary, not polyatomic, because fluorine is an element. So we're going to go ahead and we're going to combine that with our sodium fluoride. Well, what's the charge of sodium? What's the charges of fluorine? So we have to calculate that out. So let's go ahead and turn to our monoatomic ion sheet, page 13 of your packet. And we look at sodium as a +1. That's good. Sodium is a +1. And then fluorine is over here as a -1. So we have sodium and fluorine. So we're going to go ahead and get back to our question. So we have sodium is a +1, fluorine is a -1, or 1-. Doesn't matter which way you write it. Again, these are equal or opposite, so they already cancel each other out. So we do not have to crisscross. So they cancel each other out, meaning that we only have one of each one. So the symbol for sodium is Na, and then for fluorine is just F. That's going to produce or yield to magnesium fluoride. So now I have magnesium fluoride. So this is also a type 1 binary compound. So we have to go ahead and figure out what's the charge of magnesium. We know the charge of fluorine is a -1 or a 1-. So what's the charge for magnesium? So let's go back and look at our sheet. Magnesium is +2. Okay, now we knew it was going to be a type 1 because it didn't have the Roman numeral. So we know that that was a +2 or a 2+. Okay, so these do not cancel each other out. So now we do have to go ahead and crisscross. Okay, so we're going to go ahead and put our 1 here and our 2 right there. So we need 1 magnesium and 2 fluorines when we do that. So we're going to put Mg for our magnesium, our F, and we needed 2 of them, so we're going to give it a subscript of 2. What's left? Elemental sodium. Well, what does that mean? That means, well, it's just going to be sodium, so it's going to be Na. Now, our question, as always, when we have our skeleton equation is, are there any elements that are by themselves? If they are, we have to double check and make sure they're not diatomic. So magnesium and sodium are our 2 elements that are left together. We're going to go ahead and go to our periodic table in our packet. So back up to our periodic table. And which ones are diatomic? Again, as always, when I go through this, I always say the same thing. Our diatomic ones make a excuse me, there are 7 of them, and they make a 7 on the periodic table, and they make a 7 right here. So it's nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, plus the 7th one, hydrogen. So it makes a 7. There are 7 of them. There's 6 of them in the 7, and then there's hydrogen by itself. So let's go back. Well, this is not one of those, and neither is this. Okay, so we're going to go ahead and leave it just the way that it is. It is all ready to go and find our molar ratio. Okay, so we're going to go back over here, and now we have to line up the number of elements that we have and how many we have of each one. So we have magnesium, we have sodium, and we have fluorine. No polyatomic ions, we're not going to worry about that. So now we go ahead and determine how many we have of each one. Magnesium on this side, we only have 1. Magnesium on this side, we only have 1. Sodium on this side, we only have 1. Sodium on this side, we only have 1. Fluorine on this side, we do only have 1. Okay, but on this side, we have 2. So what do we start with? It's pretty obvious. We have to start with our fluorine. So I have 2 here, so I have to put a 2 over here as a coefficient. Now again, we can't change the subscripts, but we can change the coefficients. So we're going to go ahead and put a 2 right there, which makes us notable that we have 2 fluorines on this side, but it also changes our sodium, so we have 2. So what do we need to do? We're going to chase it over here. I only have 1 on this side, so I have to make it 2. And the only way that I can do that is by putting a 2 right there. And now I have 2 on this side. So I didn't affect anything else because it was by itself. So there is our molar ratio. It is 1 to 2 to 1 to 2. So we're going to have 1 to 2 to 1 to 2. As always, like to highlight that a little bit, look at it and say, can I reduce it? In this case, we cannot reduce it, so we're going to go ahead and make it bold, and then we're going to highlight it with a color, and we highlight it with our green. So there's our molar ratio for this problem. The equation is balanced, and we're going to need this later on because we're going to need to, for stoichiometry, we're going to need how many moles of something can work with how many moles of something else in a balanced chemical equation. So good luck with the rest of them, and as always, go Mohawks. Nelson out.